Hi everybody, I'm just going to run through year 2. So I thought it'd be helpful first of all to give a brief overview of the year and just the different modules we covered, and then again, similar to Sarah, focus on the major project at the end, which kind of validated all those learnings. So we started off the year with EN 9201, which is about BEAM, and we looked at various BEAMs, including BREEAM, WELL, LEED, HPI, and the Living Building Challenge. So we got a good overview of those, and then we were able to go into detail into either a LEED or a HPI experience. So I had the opportunity to carry out a full HPI on a rural new build I was working on. So I found this very interesting and was able to bring the knowledge back to the client, which was really useful. They went on to incorporate some of the ideas back into the project, which we previously hadn't maybe considered. So that was really relevant. And then in the second module, we focused on NEEP, and we learned the design builder software, which is something I hadn't used before. Previously, we'd probably given it to the consultants to worry about. So that was really good for us to kind of get in and get a proper understanding of the energy performance of the building. And then in 9205 was probably the one I found particularly interesting, and it looked at life cycle analysis, life cycle costing analysis, and circularity. So the LCCA element was good as well, because it let us consider the economic impacts of alternative design approaches and consider if they were cost optimal. So that was quite good. So looking at the major project, so the aim of the project was to explore if a modern office building design could encompass optimum environmental and circularity strategies whilst also achieving net zero energy demand. And then we also took a life cycle costing analysis as well to consider if the net zero office could be cost optimal. It was broken into a series of stages. So we looked at each of the topics at building level, and then we looked at them further at facade level. For the energy investigations, we used design builder software to explore Part L compliance and to model passive strategies for the building as a means of achieving an asset-based net zero energy demands, and also addressing any overheating issues that we came across. Circularity study, at building level, we explored design for adaptability and considered how adaptable the building could be for future residential use. And the existing facade was assessed for design for disassembly, and based on the findings, we proposed an optimal solution. The environmental building level study considered LEED 4.1 and just had a look to see, as a building energy assessment method, how it assessed circularity in buildings. And the facade study used one-click LCA to assess the embodied energy of the existing and optimal facades to consider which performed best from an environmental perspective. So the case study building was a recently constructed building in Dublin called Kildress House. It's a 7-storey office building with a basement and 6 open plan office floors. Its gross external area was about 2,850 metres squared, and it had a typical office floor plan of approximately 500 metres squared. It was cast in situ concrete structural frame, and the envelope was a mix of curtain walling, stone cladding, and brick and block construction. A detailed spec wasn't available, so we created a generic spec and based on conventional construction methods. So there's the 2 specs there on the right, and then the project began with a high-level energy assessment of the building using Design Builder. We created the 2 base case specifications. One was mechanically ventilated, the base case 1, and the one on the right had the addition of mechanical cooling. I previously, I suppose my story I should start with is I'm an architect and had worked as an associate in a urban and architectural design practice in Belfast, and had actually worked on a series of these kind of projects through England, but then took a career break for a number of years just with kids and things. So I find this very relevant because this is the kind of building I suppose I worked on a numbers of these, and hotels, all similar concrete frames, but it was always the assumption it was going to be air conditioned, so you just kind of went with that because that was what the client wanted. But when you actually started to assess it here on the energy side of things, it just got very interesting. So, for example, the addition of the cooling spec added 48% increase in the energy demand, and that then required another 130 metres squared of PV to achieve compliance. So although both cases complied, the mechanically ventilated spec showed significant signs of overheating in SBEM, but there was no understanding or numerical value of the cause of the overheating. So in order to understand the building better, we then took it a typical floor and modelled it in Energy Plus. So we focused on the second floor, which was typical for the lower floors, and then the fifth floor, where the building stepped back and had more solar gains. So the energy analysis highlighted the central zone on the second floor was the main problem for overheating. And the fifth floor also had some overheating issues. Computer and equipment loads were the primary contributor to the second floor, and the fifth floor was solar gains followed by the computer and equipment. And Energy Plus highlighted the consequences of highly glazed buildings and how the interplay of the building's thermal, energy and daylighting performance require careful consideration. And things that we came across which were quite interesting were the change, for example, in the G and the LT values of the glazing spec and the impact these could have on the lighting and heating loads. The addition of solar shading and how this could increase the heating demand and the lighting load. And the addition of natural ventilation and how this has to be played carefully against the heating load. And the internal comfort levels needed to be considered not only floor by floor, but also zone by zone. The Energy Plus analysis gave us a good understanding of how the building performed, and it showed a careful interplay of fabric systems and renewable strategies were required to achieve net zero. The net zero spec was achieved. The key changes included a highly efficient energy system, improvements to the air tightness and thermal elements of the envelope, along with exposing the thermal mass and an improved lighting spec, as well as improved controls and a large area of PV. The overheating was considerably improved. However, there was still a small issue on the central zone of the second floor. So this was explored further in the energy facade to see if passive means could address these issues. So a section of the second floor was again modelled to explore strategies including cross ventilation, thermal mass and night cooling. Working to the SIBC guidelines for overheating, a series of models were simulated in Energy Plus. So the graph here is just kind of a result of all those models. Sorry, it's a bit blurry there. But it concluded that a passive strategy of cross ventilation with 20% openable vents, along with night purging and exposing the heavyweight thermal mass of the concrete slab, significantly contributed to achieving a comfortable indoor environment. And it was also interesting just to be, with the workshops every week and things, you could kind of get feedback from what everyone else was doing in their kind of projects and what they were finding. So for example, a colleague, Patricia, also was studying the thermal mass, and she found exposing the thermal floor showed greater improvements in comparison to exposing the ceiling, as was the case in this study. So this would suggest further improvements could be made by moving service runs to ceiling level and removing the raised access floor. And it was found that a combination of the lightweight facade with a heavyweight structure was the optimal solution. So this was kind of adapted as an approach in the circularity study. So at building level, in the circularity module or element of the project, we carried out a critical appraisal of the current building design for adaptability to an alternative use with focus on residential. Currently, there is no accepted method to assess the circularity of buildings. However, we used the Flex 3 method developed by a researcher by the name of Baratz. It provided a matrix of flexibility performance indicators against which the building could be scored. The assessment actually indicated that the building structure was more adaptable than first anticipated. The large floor-to-ceiling heights and the open plan space, along with the generous 7.5 metre structural grid, allowed for greater flexibility for the internal layouts. Weaknesses were also identified, including the location of surface cores and circulation routes. So from the existing critique, an alternative layout was proposed. So the relocation there in the blue in the middle was the relocation of the stair to the centre of the core, would be better for residential use and give greater connection at ground floor level. The service voids were moved to improve access, and a modular approach to the facade proved quite important. And the precast concrete floor in lieu of the cast iron or the cast concrete reinforced slab. And they are just the proposed alternatives. So the pink at the bottom there is a retail workshop on the ground floor, and then the upper floor could be converted into a series of apartments. I think it's getting 5 apartments there on that floor. So the revised layout was also scored against the flexibility performance indicators, and the table highlights the improvements. So there was a 22% improvement in the adaptability score by simply rearranging the plan. A modular approach to the facade showed a significant improvement in circularity. So then, having a look at the circularity of the facade, the study focused on the construction and materials for a typical second floor bay on the southwest elevation. And there were 2 main components: the opaque brick block cavity wall construction and the translucent curtain walling glazing system. An investigation into the hierarchy of the system revealed there were over 20 products in its construction. The facade study focused on design for disassembly, and a series of circularity indicators were chosen for the assessment. At component and product, at an element level, we looked at design for disassembly, design for reuse, durability, and design for adaptability. At a material level, we considered toxicity, reuse potential, and waste during construction. An alternative design was again proposed. And following on from the findings in the building study and the energy study, a lightweight modular plug-and-play concept was adopted. The construction is based, so this is the proposed alternative, which is based on modular panels which are individually hung and fixed to the concrete slab with the bracket fixing. The panels are separated vertically at slab level by an insulated metal channel. The system is timber-based construction with a composite curtain walling system of timber mullions and recycled aluminium curtain walling system. The internal finish proposed is timber boarding with exposed surfaces at wall level. The suspended ceiling is omitted from the optimal design following the results from the thermal mass assessment, and the raised floor has been retained for service and heating runs. The frame system allows for various alternative facade finishes to be incorporated. The relevant levels of the building were assessed and scored against key circularity indicators to consider the ability to circulate products, components, and materials in use at the highest utility. The results were mapped as circularity fingerprints to illustrate the results of the various indicators. The proposed scheme, the proposed scheme is the optimal case on the right in each of those rectangles, and you can see it shows improvements at component level for the opaque and the translucent. Looking at the circularity of the facade, the study highlighted the following 3 areas as key drivers for circularity: functional and technical separation of the layers, for example, by separating the facade from the building at floor level. Elements can be removed or adapted without interference to other occupied levels of the building. The connections, the possibility of separating layers is very much dependent on its connections. Dry connections are optimal as they will perform well over time. And reuse potential, the ability for reuse is highly speculative. However, modular and standardized sizes would encourage the use of material banks. And then taking this on further, we had a look at it in a life cycle analysis and compared the original building against this new optimal facade. So following from the facade circularity investigations, a study was carried out using one-click LCA to assess the environmental impacts of both the base case facade and the proposed optimal design. It considered the key material contributors and exposed alternative specifications and their impacts. The scope of the study included cradle to grave over a 60-year period. The LCA shows a significant improvement in the embodied energy for the redesigned facade in comparison to the base case. The change of specification for the curtain walling was a significant contributor in this improvement. This was improved further by a change in spec to an increase in timber and less cement-based products. The LCA study only focuses on the facade. However, given its lighter construction, further improvements would be expected in the overall structure and foundation design. Circularity is currently not considered with one-click LCA except at the lowest material level. However, it is a very useful guide for the design stage. And then at a building level, we looked also at building energy assessment methods and the idea of LEED 4.1 in assessing circularity. So we identified key areas that might have good indicators. So the following 4 were identified. In the indoor environmental quality category, there was low emitting materials. In the materials and resources indicator, we had building life cycle impact reduction, building product disclosure and optimization, and design for flexibility. This one is currently only used for hospitals, but it was a good guideline and it had kind of rigid ideas of how flexibility can be added to the design. Overall, however, on reflection, we find that LEED was quite a poor indicator of circularity in buildings. Currently, the energy and atmosphere category is allocated the highest amount of points, accounting 30% of the total score, and only 10% could relate to circularity issues. However, given the improvements in operational energy in recent years, a shift of the weighting score in beams could be encouraged to address more embodied energy. Then another study which we actually carried out back at the end of the energy analysis was looking at the life cycle costing. So we considered could the Part L NZ compliant base case, could the optimal net zero be optimal over it? So the initial assessment used economic parameters detailed in the table. The capital costs focused on the elements which would be upgraded to achieve net zero and ignored elements common to both specs, such as structure or fittings. A similar approach was taken for the maintenance and replacement costs, and the study consisted of 2 parts. Part A assessed the base case against the net zero asset spec, and Part B considered the addition of battery storage and looked at the impact of this battery storage to the net zero asset, and also to include the plug loads of the building. Study A, so just comparing the original building against the net zero spec, found that the net zero to be cost optimal primarily due to the savings in the cost of the cooling equipment and the removal of the internal finishes. And then we had a look at sensitivity analysis as well, just to see if inflation rates changed or fuel escalation rates, how they would impact. So at an inflation rate of 14%, the life cycle costs were similar, and above that, the base case then started to become optimal. The fuel escalation rate graph clearly shows as the fuel escalation rate increases, the base case became less optimal. And the low energy demand of the net zero case meant that it was more resilient and fluctuations had less of an impact. B of the study, where the battery storage was added and we considered plug loads, it was assessed against each of these cases. And the sensitivity, again, it showed that the net zero asset base scenario was cost optimal. And that even the net zero with battery storage was actually cost optimal over the original base case solution. And looking at the sensitivity analysis, it showed that an escalation rate above 8% meant that the net zero case, including plug loads and battery storage, became cost optimal over the original base case building, which I think is particularly interesting given the current economic climate. So I think that's the project really. I think you can see there's a broad range and a lot covered in year 2. I joined for upskilling purposes, and I definitely feel, particularly with this year, it was extremely relevant for me. And I know, like, I left when I was last designing this type of building was probably about 8 years ago. But back then, when I think of it now, we were, you know, for different reasons, I suppose, we were looking at METSEC, we were looking at Techcrete, we were looking at pod bathrooms being wheeled into hotels, and all those things I think could make buildings a lot more circular, but we just need to kind of rethink it and see can these things still be done. But I found it a really enjoyable course. I'm currently going on to year 3 and trying to look at circularity, trying to find my question at the moment. So yeah, I really enjoyed it. Really enjoyed all the feedback from the tutors, and I really thought like things like the HPI, where you could actually get really good knowledge from not only the tutors but also other people working in the field, and enjoyed all the discussions and workshops. And
Brilliant.
thank you.